Hey guys, it's Miss Adams again. So now we're going to move on in our Units 8 and 9 test review to problems 7 and 8, where we're still finding the average rate of change, but we're going to look at the average rate of change for tables. So the instructions here say, state what type of function the table is, then determine the average rate of change for the given intervals. Then circle if the average rate of change for the function is constant, so it stays the same, or it's varying, which means the intervals have different average rates of change. Let's think back just what we've been doing and let's see if we can see a pattern here. So when we had linear functions, we noticed throughout all the example problems we've been doing, their average rates of change should be constant because whether your slope is positive, whether your average rate of change is negative, it's still increasing or decreasing at the same interval. But with exponential and quadratic functions, the intervals are not the same. So they have varying average rates of change. It's okay if you haven't seen this pattern yet, but this kind of just clears it up for you a little bit. If you see something that is a linear function, you're going to know that the average rate of change throughout that function is constant. And if you have exponential or quadratic functions, the average rates of change for those functions are going to be varying. So let's jump into problem 7. Looking at the table, my x values are increasing by 1, so -4 to -3 is 1, so on and so forth. So what we really need to look at is how are our y values changing? So I'm just going to do the absolute change in our y values. So from 0 to 3, they have a distance of 3 between those 2 points. From 3 to 4, that's a distance of 1. Likewise, from 4 to 3, that's a distance of 1. And 3 to 0, that's a distance of 3. So, in between these 2 points here, it's like we have a turnaround point. Because if we were looking at not the average rate, so that's an increase of 3, an increase of 1. But 4 to 3, that's a decrease of 1. And 3 to 0, that's a decrease of 3. It's as if our graph then did a turnaround. So, because of that, and because that's pretty symmetric there, the intervals are increasing at the same pace there. This is going to be a quadratic function. There's no little exponential jump. We're not multiplying by anything, so this function is quadratic. All right, so let's find the average rate of change for the first interval. So I feel like tables make it a little bit easier because it already tells you what the values are for each x value. It tells you the corresponding y value. So I'm going to make my own little chart here. So when x is -4, looking at the table, y is 0. And when x is -3, y is at 3. And remember, your average rate of change is your change in y divided by your change in x values. So we're going to extend our middle value here and find the differences in our x's and the differences in our y's. Your differences in your y's are going to be in your numerator. So this is going to be 0 minus 3 divided by the distances in x, or the differences in x, which is -4 minus -3. Going back to basic integer rules, when you subtract a negative, it's the same thing as adding a positive. So 0 minus 3 is -3, and -4 plus 3 is going to give me a -1. This will simplify to +3 for that interval. Let's look at the average rate of change for the interval from where x is -2 to where x is -1. So I'm going to make my table here again, or my little chart. So I've got -2, -1, and go back over to the table where x is -2, y is 4, and where x is -1, y is 3. Slide this out and find the differences. So in your numerator, you're going to have 4 minus 3. because that's your differences in y values. And in your denominator, you're going to have -2 minus -1 because that is your differences in your x values. Subtracting a negative with our integer rules would mean we're adding a positive. So on the top, so in our numerator, 4 minus 3 is +1. And in our denominator, we have -2 plus a +1, which is going to give us -1. And this simplifies to -1 as our average rate of change for the second interval. Comparing the two, so I have 3, I have -1. This is a quadratic function, so I know that the average rate of change throughout the whole function is going to be varying. Let's go on to problem 8. So state what type of function the table is once again, then circle if the average rate of change for the function is constant or is it varying after finding the average rates of change for the given intervals. So once again, our x values are increasing by 1 for this table because -2 to -1, that's an increase of 1. So while our x values are increasing by 1, let's see what's happening to our y values. 9 to 6, well, that's decreasing by 3. 6 to 3 is also decreasing by 3. 3 to 0, that's decreasing by 3. And 0 to -3, that's decreasing by 3. But those are the same. It doesn't change. So this is a linear function because I'm adding or subtracting the same values from my y values every time. So I can already say that this is a constant average rate of change because, as you can see, it's not changing here. But let's solve for it algebraically just to make sure. So let's find my table, or let's make my chart for this first interval. So we're in x equals -2 to where x equals -1. Looking at the table here, when x equals -2, y equals 9. And when x equals -1, y equals 6. We're going to find our differences here. And we will have the difference in y's divided by the differences in x's. So I'll have 9 minus 6 divided by -2 minus -1. All right, so 9 minus 6 is going to give me a +3 on top. And when I subtract a negative, I'm adding a positive. -2 plus +1 is -1. So this simplifies to an average rate of change of -3 for the first interval. Now on to the second interval. So I'm looking where x equals 1 and where x equals 2. So let's find those y values. When x equals 1 in the table, y is going to equal 0. And when x equals 2 in the table, y is going to equal -3. So once again, we'll extend our line here and find the differences in our x and y values. So in our numerator, we have 0 minus -3. And in our denominator, we have 1 minus 2. When you subtract a negative, you're adding a positive using your integer rules. So 0 plus 3 is +3. And 1 minus 2 is -1. And if you simplify 3 divided by -1, you will get an average rate of change of -3. Comparing those, -3 and -3, those do equal each other. So therefore, the average rate of change for the function is constant. All right, guys, have a great Bulldog day.